Now let's talk about the shell. I've already mentioned it. It's a program that runs on the other side, and there are fancy modern graphical environments on Linux, but what we are using is a text-based interaction. It's more efficient, and you are able to automate processes using this text-based system. So it looks like this. You have, as explained, your terminal, and then you have a prompt. It waits for you to enter some commands, and then it will then interpret your command and execute the program, and then print the output. So we're going to take a look at this loop that then explains what the shell, the program that receives your input, your text input, and interprets it, what it's doing. So first, let me also open up a terminal. So this is a terminal. I'll make it a little bit larger on macOS, and as you see here, I have my local name at the name of my machine, and this is also the current working directory that I'm inside right now, and then this is just some character to show that here is the prompt, and then I can enter here some commands, for example, here to connect to the training machine. And as we see here, I entered my password. It wasn't shown. I just pressed enter, and then I was greeted with a default message, and then I got the prompt here. Now, what you can do, what I will also do regularly, is to clear the terminal. So if you press Control L, then you will see it moves up. So I have a little bit more space here, but you can always scroll up in your terminal, as you see here, the scroll bar. And now I have again my username at the machine name, and then where I am right now, and we have the tilde sign. So what does it mean? So this is the account where my commands are executed under. So as you know, there are multiple users at the same time. So every user has a name, and in this case, this is my name on the machine, and I see I'm on the training machine. So you can differentiate all the time by looking at the prompt under which context your commands are running. Are you running a command locally on your computer, or is it on a different machine, for example, the training machine? So you always know where you are, and you always know in what folder you are, and this tilde is an abbreviation for your home folder. So I'm inside my home folder right now. And then we have the $sign and the prompt, as explained, is a place where you can enter a command and then press enter to give it to the shell. And the shell is basically the program that prints this prompt, waits for your command, interprets it, and then runs it. So we can run a command, for example, ls, and ls will simply print a listing of files and directories. And if you just run ls, it will list the things that it finds inside of the current working directory, which is the home folder in this case. We can also run a different command, pwd, and this command means print working directory. So we see we are right now at this path in the working directory. Now, as you see here, in these types of commands, you enter them, you execute them, and then they will print something. And after they are done with printing, the output that you see in the terminal, you will get back the prompt because this command ended, it exited, and then the shell sees that the command is done and then prints the prompt again and prompts you basically to enter the next command. One important part is there are multiple shells. In this case, we are using bash. And I've always said the input that you're giving is interpreted. It's not simply executed, it's interpreted by the shell. And an example for this would be that you can substitute some parts of your input. What do I mean by that? If you're using the echo command will simply print the thing that it is given as an argument. So we can give it hello, and it just prints hello. And I can give it a second argument, hello world, and it just prints these two arguments. Now what I can do is I can use variables because the shell is also has a little programming language, a scripting language, which is just called the shell scripting language. And here I can, for example, use this command, this expression here to say or to access the content of a variable. So we say dollar, and then the shell will interpret what comes next as the name of a variable. So there are some predefined variables, and in this case, this is the path to the shell that I'm executing. We are using bash. So what happens here? Bash will get this input, and it will see, okay, here is a dollar sign, so I will take this expression and I will substitute it with the value of the variable. And then this argument is substituted and passed to the echo argument. And therefore, this thing is substituted by the value of the variable called shell. As we see here, it gets two arguments, hello, and then this sequence of characters that is inside of the variable. And we can also do some other things. We can pass it as one argument without the space, and then it's just substituted in here as part of this argument. And one important thing is, in this case, these are two arguments, and this is here one argument, because arguments are interpreted by bash as be split by a space. So if you put a space somewhere, then it will think it is two arguments. And we can also use these parentheses to tell the shell that it should treat this as only one argument. But we can also see here, if I continue here with some other characters, suddenly this whole thing disappears because bash thinks, okay, this is a variable name, and this variable name is not defined, so it substitutes the whole thing with nothing. So we see this is also an interpretation of your input, and we will later see in this course how to use this to make use of it to automate some tasks. Another important thing when you're using the shell, you can scroll through your previous commands just by typing up and down, and then you will see your previous commands, and you can then go left and right to, for example, change the arguments and run the command again. And what we can also do is we can use the auto completion. For example, if I start with an L and then press tab, then Bash will give me a list of available commands that start with L, and depending on how many characters I'm using here, it gives me a different list of the commands that match this. So in this case, I just want to use ls. And another thing is this also works with files and folders. So if I want to look at the content of the data folder that's inside of this inside of my home folder here, then I can just press Enter D, press Tab, and then it will be auto-completed to the name of the available file and folder, and then I can take a look at the input. Yes, please.
Would the autocomplete doesn't work if I am using the Windows PowerShell?
So when you're using the PowerShell and then SSH into the different system, then the shell that is interpreting your commands is running on the different system. And then in this case, this is the bash shell, then it interprets your input, and therefore it then would work exactly as I demonstrated it. And if there may be some problem with the interpretation what key you're using. So this is often you can, for example, with page up and page down, usually you can go to the start and end of the line. This may not work completely. So you can use Control A and Control E to get to the start or end of a line. And do you have a problem with the can you press it again? It doesn't work? Okay, so maybe you have to press 2 times. Yes. Okay. Let's see what I've forgotten from the slides. So we looked at the prompt, and we looked at navigating, and we looked at that Bash is basically a little programming language and interprets your input and changes a little bit. And yes, there is also if you're running a longer running command and you want to interrupt it, for example, in this case, I'm running sleep, and sleep waits for the amount of seconds that you give it as an argument. Therefore, we see the bash program waits until the command that you executed is done. So sleep is not done until it's done sleeping. And if you want to interrupt it, you can ask it to interrupt by using Control C. And as we see here, then this Control C, this head C is printed here. So the bash tells you, okay, I try to interrupt the command. And as we see here, it worked. So sleep will can be interrupted and then just stops sleeping and exits in this case. And then we will get the prompt back. So you can interrupt most commands. Now, as explained, when you are running a command, you can give it multiple arguments, and the arguments are then delimited by a space, or you can use these double quotes to give it a sequence of characters that also contains a space, but then is passed as only one command. I can simply demonstrate this. I can create a folder. So in this case, I did not create one folder, I created two folders. So we see here, I created two empty folders because this is interpreted as two arguments. So as first argument hello and second argument world. And now if I go back and try it with the double quotes, then we also see here ls shows this with these single quotes to say, okay, this is actually one thing. So let's see. I can also use this escape, the backslash to escape the space, so it isn't interpreted as a delimiter, but just as a character. So there are many characters that are special in this sense and maybe need to be escaped. Pardon? So if you can create a file, so you are in your home folder, and so what's the question? Folder. So we will like in two slides, we will have the hands-on section, and we can look at your questions, and then we can figure all this out. So as explained, there are also these variables, and they are called environment variables because they are passed to other processes. You can define a variable. For example, there are predefined variables home or path, but you can also define your own, and they are, can or cannot be passed to a different program. So you can simply use them as local variables, or you can say, please pass them to a different command. And there is this env command that prints all of the variables. So they are basically just key value pairs. So shell contains this, language contains this, and so on. Now I can define a new variable and use it. But if I'm running env, you will see it is not listed because env is a new program, a new process, and foo is only a local variable. If I want to pass this variable to a program, there are two methods. Basically, I can type it directly in front of the command and then use a space as a delimiter. So now it is also passed to env, and we will see env also lists it because I explicitly passed it to. But in this case, it is not stored as a local variable. For example, I can use this. So this is env prints it. But if I try to use it, then it's empty. And there is this export command. And with this, it is a local variable, but it's also passed to other commands. So why is this important? This is how to give more configuration and more arguments to a program, which is not a normal argument. So we just saw that we have this way to pass arguments to a program, and we have these environment variables to pass more information to a program. This is often used if your program is using some libraries, because you don't want to implement all the things anew. You're using already existing libraries. For example, a library in your calculation program that helps your program to efficiently calculate some linear algebra things. So you don't have to implement it yourself, you're just using this library to execute it, calculate it faster. And now this, it would be complicated if the if you would need to have some options in your normal arguments that you would need to pass down to the library. For this, you can have your normal arguments for your program and instead use the environment variables to pass, for example, some configuration to the library. The library can, when its own code is running, look at these environment variables and then can be configured, for example, to use a certain different type of implementation for your linear algebra functions. This way you can pass these configurations to a certain library that is used by a program, for example. As explained, we had this variable substitution example, and we've seen that it depends on how the bash interprets your input. And we also see that in this case here, this completely disappears, but there's another way to specify the variable name. If you put these curly braces around, then you can also just put it back to the next characters here. And then it's interpreted as expected, or if you then use a different character that to delimit here the argument, and then bash just uses this shell name as a variable name. And we've seen we can use the double quotes to also use spaces in your argument, or you can use single quotes. But in this case, this substitution is not happening, and we get the literal dollar here and the variable name, because then bash is not substituting this variable name. And we have some other characters, as mentioned, for example, the ampersand, the pipe, the backticks, that have special meaning, that are interpreted by bash. But if you want to use them, for example, inside of an argument for some reason, this can happen. Then you can use the single quotes, so they are not interpreted, or you can use the escape character, so a backslash and then the character. Now, here's again a little table with some of the commands that we've seen.